Welcome everyone, I am Karthikeyan and today I will present our work on building the foundations for an automated multimodal tutor for educational videos. This work is a collaboration between researchers at IIT Delhi and Microsoft. Let's start with why we are doing this. Educational videos have democratized learning, enabling students to learn at their own pace, but it lacks interactivity. When a student gets stuck on a complex concept, their only solution is usually a discussion forum. This introduces a delay which stalls the learning and lowers the engagement. Our vision is to bridge this gap by building an automated tutor, which would be a multimodal QA system that can answer student queries instantly. To achieve this vision, we made three primary contributions in this paper. We curated EduVidQA, a novel dataset containing over 7,000 videos and 200,000 QA pairs. We found standard metrics insufficient, so we proposed a robust GPT-4 based evaluation framework tailored for education. We provided a comprehensive benchmark of existing LLMs and VLMs on this new task. Creating a reliable dataset was our first hurdle. We started with the LearningQ dataset, which scrapes Khan Academy, but it contained many irrelevant or text-only questions. We applied a rigorous two-phase filtering process using GPT 3.5 and GPT 4 to remove noise. Crucially, we focused on math and science domains, as these are most likely to require visual understanding. And we got around 7,000 videos and 200,000 QA pairs. We then subsequently created a more challenging subset comprising of math and science questions spanning around 18,000 QA pairs, where the model must understand the specific video frame to answer correctly. Here is a concrete example from our dataset. The student asks a question about a specific timestamp. To answer this, a model cannot just rely on general knowledge. It needs to look at the video frame, specifically the equations written in purple and green. This demonstrates why this task is truly multimodal. Text-only models often fail here because the critical information is on the blackboard. We didn't want a dataset of simple factoids, so we analyzed our questions using Bloom's taxonomy to understand their cognitive complexity. While the majority fall under understanding, which is expected in a tutoring scenario, we see a healthy distribution of high-order thinking skills like application and analysis. This confirms that our dataset is a challenging benchmark requiring deep reasoning, not just pattern matching. One of our major findings was that standard NLG metrics are broken for this domain. If you look at the correlation metrics, the top row represents human judgment. You can see that traditional metrics like Blue and Rouge have extremely weak correlations. Even the semantic metrics like BERT score only reach 0.32. This is because in education, there are many ways to correctly explain a concept. Training or evaluating on a single gold answer using n-gram overlap penalizes valid alternative explanations. To solve this evaluation crisis, we designed a custom evaluation framework using GPT-4. Instead of a single score, we evaluate on four critical aspects. Correctness, which would ensure accurate information preventing misconceptions. Coherence, which would ensure that the explanation is clear and logical. Visual grounding, which would check if the answer references the video content. And relevance checks alignment with the question. Now this composite score correlates much better with the human judgment. We benchmark various setups. The columns show our custom metric scores. We observe in the rows 2, 4, 6, 8, and 10, adding the transcript, that is providing more textual context, consistently improves performance across all models. In row 10, GPT-4V significantly outperforms text-only models, achieving a score of 4.55. While GPT-4V is good, it still lags behind human performance in row 12, particularly in complex visual reasoning. To understand where models fail, let's look at this error analysis. Here, instructor has written several equations for the sides of a dissected rectangle. Even our best model GPT-4V failed here. It got confused by the spatial layout of the equations on the blackboard. It incorrectly matched the equations to the sides of a rectangle, leading to a hallucinated proof. This highlights that the current VLMs still struggle with dense visual information and spatial reasoning. They can read the text, but they don't always understand the structure of the text on a blackboard. They often get confused by incorrectly framed questions. In conclusion, we have taken the first steps toward multimodal QA in education with the EduVidQA dataset and a new evaluation method. However, open questions remain. How can we improve smaller, cheaper models to perform well in this domain? And how can we fix the spatial and temporal reasoning errors we just saw? We invite the community to explore these questions. You can access our code and dataset via the QR code and the link provided. For any queries, kindly mail us. Thank you.